All right, guys. So let's tackle some more of these. So don't forget from our last video, page 725 gives you some trig identities. So one of the key things I want you guys to bring away with that is I want you to the trig identities are used to, number one, make, or let's say, let's not say make, let's say change. There's my cat going crazy. All equations into sine or cosine if possible. And number two, sometimes it's got to be tangent. We can say tangent also. Number two, to simplify the equations. Equations. All right. So we've got a couple of reasons why we use these identities. So one of them is we get this problem like this, and it's like, what the heck? It's got a cosine, it's got a tangent, and it's got a sine squared. So the tangent's kind of the thing that bugs me right off the bat. So I'm going to use the identities to say, okay, what is tangent? So from my identities, and I'll put my identities over here on the right with this one. So my first identity I'm going to use is I'm going to use the identity that the tangent of theta is the same as the sine of theta over the cosine of theta. So I'm going to let tangent of theta equal the sine of theta times the cosine of theta. So I'm going to rewrite this. I'm going to change this because I'm saying I'm letting tangent equal something else. So that's going to be the sine of theta over the cosine of theta. That's my new piece. Let's bring everything else down that's original. So we're going to get the cosine of theta. Since it's a fraction, I'm going to go ahead and put it over 1 so you guys can see it. Minus sine squared of theta equals 0. Now, if I look at this, wait a sec, those are going to cancel out. So those are going to simplify because cosine of theta over the cosine of theta is 1. So I only have a few things left. I still have my original sine squared theta left. And I have my sine of theta left. That's a horrible thing. That's not much better, but we'll take it. So now I have everything in sine. I can solve this problem now because if I look at this and I say, oh, okay, if I treat the sine of theta and the sine squared of theta as an x value, so we can rewrite this again if you'd like, but I'm not going to rewrite it this time. I'm gonna let you guys know that I'm just going to treat it just like its own variable. So the common factor between these two is just the sine of theta. And I'm going to take out a sine of theta. Remember, when we're factoring, I'm factoring here. When we're factoring, we're just dividing. So I'm going to move my common factor out front, sine of theta, and I'm going to put my parentheses back. And now I'm going to write the mathematical equivalent of what's inside. Sine of theta divided by the sine of theta is 1 minus sine squared theta divided by sine of theta means I only have a sine of theta left. So now, when I'm looking at this, now I've got a problem I can work with. So I'm going to take my first sine of theta. Well, I'll just take the one that I already have the color. So this one's going to be set equal to 0, this factor. And my other factor is going to be set equal to 0. Sine of theta is equal to 0. So where is it 0? At 0 and 180 degrees, or it's going to be at 0 and pi, depending if we want it in radians. And then we have this one here, which we need to solve a little bit differently. Take a few more steps. Subtract 1 from both sides gives me negative sine of theta equals -1. Divide through by a negative, the sine of theta equals 1. Where does the sine of theta equal 1? If I use the inverse tangent, theta is equal to 90 degrees, or pi over 2. So those are my answers here, and right here. Which kind of goes with our first step. We wanted to change all equations into sine or cosine. So I took tangent here. I changed it into sine or cosine based on an identity on page 725. And then from there, I got a problem that's a little bit different. So I simplified the equation by factoring, and then I ended up getting two different equations that I could factor. All right. So let me rewrite this one here. The page wouldn't. So we're doing what are called double angle formulas. I'll rewrite this so you guys can double angle. I should say double angle identities. And they're on page 745. Now, with the double angle identities, there's a few new identities that you got to deal with this week, but they're meant to help with different looking problems like this one. And if you are watching the video, you noticed right away and are paying attention that this is new right there. That makes, those are double angles. There's two of them, two thetas. We don't want those. We want them in theta. So we've got to come up with an identity that makes it a little easier for us to deal with. So if you go to page 745, right there on top, it has a couple of cosine identities. So cosine 2 theta identities, there's three of them that it gives you actually. So you can work with any of the three. So since we're dealing with another term of cosine, I'm going to find one that has cosine only. And if you look at the second one says 2 cosine squared theta minus 1. So that's the one I want to deal with. So this is again from page 745. So I'm going to do that crazy thing that I always do, and I'm going to say let 2 cosine theta equal 2 cosine squared theta. So we're going to rewrite it here. There's 2 cosine 2 theta, and I'm telling it to equal 2 cosine theta, 2 cosine squared theta minus 1 from the identity on page 745. So this becomes 2 cosine squared theta minus 1. And then my crazy cat's back in the background. And then we have 3 cosine theta equals 1. So now I have everything in cosine. So let's clean this thing up. So I'm going to get 2 cosine squared theta. I'm just going to combine those two. Well, not combine, rearrange it. 3 cosine theta. And then I've got minus 1, and I'm going to subtract 1 from this side, minus 1, that equals 0. So if I move this up a little bit, guys. So if I'm dealing with this is going to be -2. So I get 2 cosine squared theta plus 3 cosine theta minus 2 equals 0. Cosine squared, cosine. All right, so then I can treat this as a factoring problem by letting x equal cosine of theta. So that means that I get a different looking problem here. For those of you that like to do it this way, 2x squared plus 3x minus 2 equals theta. Now, however you want to factor this is fine. I'm going to get 2x and x, so I split those two up, and then I know that I need 3x in the middle. So that means that -2, that's a positive, and this is going to be a -1. So let's double check my math. 2x times x is x squared. negative 1 times 2 is negative 2. And then negative 1x plus 4x gives me 3x. So those are my factors. So now I'm going to reinsert everything back into this one, but using cosine. So then I get 2 cosine of theta minus 1. And then I get cosine of theta plus 2 equals 0. Now, if I set each one equal to 0, and I get cosine of theta plus 2 equals 0, I'll start with this one on the right first. I'm going to get cosine of theta equals negative 2. That right there will become no solution. So that means I only have one solution over here. And so that we get cosine of theta equals 1, cosine of theta equals 1/2. And depending on the domain they want, and I didn't give a domain, let's move this up just a little bit more, guys. Cosine of theta, 1/2, if I do the inverse, is going to be theta is equal to 60 degrees, or pi over 3. And then it also could be 300 degrees, or it'll be 5 pi over 3. So those are your two answers right there. I don't know why I put percent, guys. 300 degrees. 300 degrees. 60 degrees. There you go. All right, guys. So identities are a big thing for us this week. We'll do some more in class.